What's up guys, my name is RCharchar and I got another banger of a tutorial for y'all today. So, you might know how to make a dash. In fact, probably everyone knows how to make a dash because it's probably one of the first tutorials you ever looked up. But what if you wanted to tell the player information about their current dash status, such as perhaps maybe how many dashes they have? What is the cooldown status of their dash? Are they out of dashes, etc, etc, etc. And more importantly, what if you wanted it to be modular, to where if you had different classes with different dash cooldowns and dash amounts, that can be accurately reflected in the UI. Well, today in this video, in this tutorial, I'm going to tell you all about how you can make a dynamic UI that automatically adapts to whatever your dash parameters are. So, without further ado, let's get into this video. So our Dash UI has two parts. The first part is building the element at runtime. So based on how many dashes the player has and its cooldowns, etc., all of that is taken into account and we build the element out at runtime. The second part is setting the fill percent of the indeterminate amount of progress bars, because the amount of progress bars can be anywhere between 1 to 11. We have to have a function that can accurately update the progress bars no matter what the amount of progress bars are. Alright, to start off with, let's do a little bit of housekeeping. If you've watched a Dash tutorial, what they probably would have taught you is pretty much just, launch the character, and then, do a delay, and then once you do the delay, you then stop the movement immediately, and then you finish the dash, yada yada yada. And then if there's like a cooldown system, they have their cooldown system, and you follow through with that, and then that's it. So my dash system pretty much does the exact same thing, just a little quick skim. Basically, if you have dashes, we decrement one of your dashes that are available. Then we just simply disable the input, stop the movement immediately, set the character movement to flying, and then we launch the character by basically getting the last input vector, and if there is no input, we just get the forward vector, and then we multiply that unit vector by a speed, and then we provide that as our launch velocity. Then we get a delay time by dividing our dash distance by our dash speed, and then we delay by that much time. Then we stop our movement, we set our character movement back to walking, and then we enable input, and then we call this function dash finished, and dash finished just takes care of all of the post dash stuff. So first off, we reset the do once up here with dash, so that way the player can input a dash again. But then also we do our cooldown system, and our cooldown system is pretty simple. We just pretty much, if the cooldown isn't running, we go ahead and start running the cooldown, and then once the cooldown is done, we increment the dash amount, and then if it's not equal to the max number of dashes, we run the cooldown again. Otherwise, we don't run the cooldown again, and then we just simply reset the do once down here. And that's pretty much how the function works, or the dash system works. So if you just want to quickly kind of go kind of recreate this on your own, here's the first half of the dash system. Here's the second half. And I'm sorry, here is the third half, because that's mathematically possible, I guess. I don't know. But anyways, and then once you finish the dash, you call dash finished, which is just a custom event that handles all of the cooldown stuff. So first off, we go through the sequence, we reset the do once, and then the second part of the sequence, we just do our cooldown management. So pretty much we delay by a cooldown, and then we increment our dash amount, and then we determine whether or not it's equal to the max number of dashes and go from there. So yeah. Hey, it's me, RCharchar, and I'm currently editing the video, and I completely forgot to mention what the variables I have set up for the dash. So dash speed is basically how fast the dash is moving. Dash distance is how much distance the dash will travel. Dash amount is a counter variable. This doesn't actually dictate the actual dash amount that the player has at max. Instead, that's max number of dashes. Max number of dashes is what we set dash amount to at the beginning of the game, and also we'll use this in the UI to kind of build out our progress bars for the dashes. But otherwise, it doesn't have much during runtime purposes outside of just simply setting dash amount, because dash amount is, again, the actual amount of dashes the player has at their disposal. And then dash cooldown is how long it takes for a dash to refill. So yeah, let's go ahead and start creating the UI element. So what we're going to go and do is first we're going to kind of create a parent HUD. So, and then we're going to create the actual UI element for the dashes. So we're going to create two widget blueprints. The first one is going to be widget blueprint underscore UI, WBP underscore UI. And here it's pretty simple. We're just going to get a canvas panel, place it in the world, and then inside our graph editor, we're going to open that up. We're going to go to variables, call it player ref, make this of type BP underscore whatever your player name is. In my case, it's BP underscore third person character. And then what we're going to do is I'm going to put this eyeball to be open, which will make it instance editable. And then I want to expose this on spawn. Compile it and save. And then what I want to do is inside BP underscore third person character is on event begin play. After I do all this stuff that's already in the template, I'm going to go ahead and I'm going to create a widget. And then I'm going to get widget blueprint underscore UI. Player reference, I'm going to drag out of that, and I'm going to get a reference to self. And then I'm going to add this to the viewport. Sweet. Now the next thing we need to do is go ahead and make the dash UI element. So how do we do that? Well, let's open up our blueprints folder again. Right click, user interface, widget blueprint, user widget, and then just call this WBP underscore dash amount element. Let's double click to open this up. Now, here's the difference between how we're going to design the parent widget blueprint and then this element blueprint. So pretty much the parent widget blueprint is going to hold all of our elements. So, in the case of a video game, you might have, in the case of a shooter, you might have an element of your ammo that's down here in the bottom right corner. You might have your health somewhere in the middle, or maybe off to the left side of the screen. You'll have your crosshair, which could be another element. You will have your scoreboard, which would be another UI element, etc. There's a lot of things that are elements, but they all get placed together into a parent blueprint widget, which is what we're creating right here. That's kind of the purpose of this. So what we're going to quickly go ahead and do is inside widget blueprint underscore dash amount element, we're going to go ahead and we're going to search for a horizontal box, because we're not going to design this like the master widget or the parent widget, because in the parent widget, we want to have a canvas panel and we want to be able to move things around. Here in this element, we don't care about moving things around. We just care about having things existing in the widget itself, because we'll do all the sizing for this element inside the parent widget, if that makes sense. So let's go ahead and create a horizontal box. Click this horizontal box here in the hierarchy, and let's make it variable. And the reason why we're doing this is because that way we can add progress bars dynamically during runtime into this element. And real quick, before we continue, let's go back to our widget blueprint UI, and then here in the palette, let's search for widget blueprint underscore dash amount element. Drag this and put this underneath the canvas panel. Now we have our dash element that's right here. Let's go ahead and move it. So let's open up our anchors. Let's hold control and then click the middle one, which is the one right here. Set its alignment 2.5 and 0. And then let's just move this down by, say, 100. Boom. And now we have our dash element right there. So real quick, last thing we're going to do is let's increase its size to 500. And then let's increase its size Y to 80. And boom, we have that set up. Then here in the widget blueprint dash amount element, let's go into our graph. Now, the first thing we need to go ahead and do is we need to go ahead and get a player reference. So let's go ahead and create a new variable, call it player ref, make it of type BP underscore third person character, or whatever your character is called in your project. And then what we're going to do here is we're going to go ahead and in event construct, we're going to go ahead and we're going to type in cast to BP underscore third person character, or whatever your character or whatever your player blueprint is called. And for the object, I'm going to get player character. Then all I'm going to do is just drag this player reference, put it, and then just set it based off of that. After I get that done, now it's time to set up how the widget is going to look. So since we want this widget to be dynamic, to be able to adapt to different values within the cooldown system, or or how many dashes the player might have, we need to be able to build this during runtime. So the way we build this during runtime is we need things to be variable. Hence why we got this horizontal box and we have it variable. And the idea I have behind this widget and how it's going to be, this element and how it's going to be built, is I'm going to effectively stack progress bars inside this horizontal box, and then I'll have references to them, which then I can modify when I am adjusting their fill percent based on how many dashes the player has and the cooldown of the current dash that's being refilled. First, we need to go ahead and get all the progress bars into this horizontal box. So let's go ahead and go back to our graph. The first thing we're going to go ahead and do is after we set our player reference, the next thing we want to go ahead and do is we just simply want to get a for loop. Now, make sure it's not a for each loop, you just want a for loop. And our first index will be 1, and this is assuming that that the player has access to at least one dash. And then what we're going to go ahead and do is we're going to go ahead and drag out from our player reference, and we're just simply going to get max number of dashes. And what we're going to go ahead and do is we're going to plug this into our last index. And what this does is we loop over this for loop for however many dashes exist within the character. So if there's one dash, well then the first and last index will be 1. This loop only runs once. If there's 5 dashes, then the last index is 5, the first index is 1. The loop will run 5 times, and we can build out the dash meter. So let's go ahead and start adding the progress bars. So any of the default items in the palette are not actually widgets in Unreal. They're actually considered objects because they don't derive directly from the widget class in Unreal. So because of that, if you were to go out and just type in create widget, you wouldn't be able to just simply get a progress bar. So if I type in progress bar, it's not there. So what we actually have to do is we actually have to construct object, because everything in the engine derives itself from the object class. So because of that, we can create during runtime a progress bar or any of the other default Unreal elements or any of the default Unreal UI elements using the construct node. So for our class, we're just simply going to get progress bar. And then once we get our progress bar, what we're going to go ahead and do is we're going to right click out of this return value, promote it to a variable, and then just call this progress bars. And yes, your eyes do not deceive you. I called this progress bars plural, and the reason why is because we're going to go ahead and delete this, because what we're going to do is we're going to click on this progress bars, and we're going to change its container type to an array. And you might see where I'm going with this, because the next thing we're going to do is we're going to drag this progress bars into our graph editor, and we're going to go ahead and drag out, and we're going to get add. Then we're going to connect this into construct progress bar, and then get our return value and put it and add it to our array of progress bars, which is great. Now, it isn't enough to just simply create the progress bar, because now we actually need to make it a child of the horizontal box. Otherwise, it won't be associated with anything, and thus it won't actually get displayed onto the screen. So the way we fix that is we make it a child of the horizontal box we just created. So drag out, get the horizontal box reference, drag out, type in add child, and make sure it's add child to horizontal box. The reason why we were doing this is so that way it's with our return value is already it makes the progress bar already slotted to the horizontal box, and we can manipulate the progress bar as it pertains to the horizontal box. And the reason why we want to manipulate the progress bar as it pertains to the horizontal box is because whenever you add a new element by default, so for example, if we just got a progress bar, and added it into our horizontal box, what you'll notice is it's trying to take up the least amount of space it's allowed to take up. And the reason why it does that is because its sizing is set to auto instead of fill. And also another thing we need to do is, let's say for example we have this set to fill, and then we just do another one of these. It's almost impossible to tell the difference between the two unless you know this is very, very faint line in between them. So another thing we have to do between both progress bars is we also have to give them at least some padding, like for example 5, a padding of 5 pixels. And what that's going to do is that's going to give us a little bit of a more visible separation between the two progress bars. But that's not done by default when we create the progress bars and add them as children. So what we have to do is we have to do that through code. And that's why we're using this special node called add child to horizontal box. Because that way our return value has the progress bars already slotted to the horizontal box. So all we have to do now is drag out of here, type in set size, then split the structure pen, and then yeah, this is perfect. Size fill rule is fill, and then our in-size value is 1. That's what we need to do. And then the next thing we need to do is drag out this return value again, and then type in set padding. Then just split the connect this over into set size, and then split the structure pen. And I'm going to set it all as 5. However, feel free to set the padding to whatever you feel like is right for your project. And then boom, we've just created the setup. So now, if we were to go ahead and play this in the third-person map, you'll notice that because I currently have it set up to where I only have 1 dash, there's only 1 progress bar. But if I were to go to my third-person character, go to max number of dashes, and set this to 3, compile this and save, you'll notice that I now have 3 progress bars. And there we go. The first part of this setup is complete. So the next thing we need to go ahead and do is we need to change the fill amount of the dash bars to accurately reflect how many dashes the player has and what is the current recharge amount of the dash that's currently recharging. So how do we do this? Well, unfortunately, right now, our current implementation of the dash system doesn't do us a lot of favors. If you've watched a tutorial, they'll probably have you do a delay, and then from this delay, once it's done, then you reset your dash. Unfortunately, we can't get much information from this delay. And because of that, if we were to keep with the delay system, well then in the actual dash amount element, well then we would have to set up another delay that's completely decoupled from the third-person character, which means it doesn't accurately reflect and has the potential of misleading the player as to the actual state of their dash amount and their dash cooldown. So how do we fix this? So the fix actually is, instead of calling a delay, we actually call something called set timer by event. And what this will do is this will give us a return value that represents the timer at its current state. So for example, if the delay was a delay of 5 seconds and there's 3 seconds remaining, well, we couldn't access that by calling a delay. But if we did the same thing with this function down here and we set the time down here to 5 seconds, well then if there was 3 seconds left in this timer, we could access that information of how much time in total is this timer and how much time is left in the timer. We can access that. So because of that, wherever you have your cooldown for your dash, so if you're just doing a dodge roll and there's a cooldown between your dodge rolls, go to that delay and just replace it with the set timer by event function. Alternatively, if you're doing more of my system where the player has dashes that go onto cooldown and they kind of recharge over time, then go to your cooldown management system, and from your delay, just simply remove it. And I'm going quickly on my end, just remove all this code, quickly remove it, and instead just get the set timer by event function. Now we're not going to immediately implement it to the execution line because there's actually something we want to do before we set the timer by event. So in my scenario, hold on, I just realized I did something on accident. So I need to quickly add back this do once. So in my scenario, or at least in my implementation, the way I do this is pretty much whenever the cooldown is not active, as in it's not running because the dashes were full, then pretty much we start the cooldown system, and then this do once gets closed, and then basically we can't restart the cooldown system until all the dashes have been refilled. So, so because of that, this is how I'm going to program this set timer by event. First, from the return value, I'm going to right click, I'm going to promote this to a variable, and I'm going to call this dash cooldown timer. Incredible. Dash cooldown timer. And then before I call set timer by event, I'm actually going to get my dash cooldown timer, and I'm going to type in, drag out of it, and I'm going to type in clear and invalidate timer by handle. And what this is going to do is this is going to make sure that this timer reference has nothing associated with it. So that way it's completely null and it's a clean state. So that way we don't have any sort of messy, funny edge cases happening because we set a timer by event on a active timer. So we're going to go ahead and then, after we clear and validate the timer by handle, we then drag into set timer by event, and then we set the dash cooldown timer. Now, real quick, for time, what we're going to go ahead and do is we're going to get our dash cooldown, and we're going to feed it into the time. Then if you want, what you could do, if you want to have any sort of initial start delay or any initial start delay variance, which basically means a variance of plus or minus x of seconds, you can also add that into here. But for my system, I just want to keep it simple. I just want the dash cooldown to be persistent, to be constantly a number that I decide. The next thing we want to do, though, is we want to go ahead and we want to feed an event. So whenever the dash cooldown finishes, what do we do? Well, obviously we're going to refund a dash. So how do we do that? Well, what we're going to do is drag out of this event delegate, drag out, and then type in add custom event. I'm going to call this refill dash. Now that we've refilled the dash, what we're going to go ahead and do is we're going to go ahead and get our dash amount, and we're going to increment our dash amount. Of course, if you just have a single dash system and all you want to do is just display like, oh, your dash is on cooldown and done, then all refill dash is really going to do is it's just simply going to open back up your character's ability to dash. But since I'm doing a whole cooldown management system because the player can have multiple dashes on my end, I'm going to do this. I also increment the dash amount. And then what I'm going to go ahead and do is after I got this done, I'm then going to go ahead and just get a branch statement. Then from this increment int, I'm going to go ahead and drag out. And I'm going to go ahead and check to see if it's not equal to the max number of dashes. If this is in fact not equal to the max number of dashes, then all I want to do is I just want to restart the chain. So I want to go back up here, clear and validate timer by handle, set timer by event, etc., etc., etc. However, if I do equal the max number of dashes, then what I want to go ahead and do is I just want to drag out of this false node and reset this do once node, so that way because now the cooldowns are no longer active, so because of that we should restart the cooldowns whenever we finish performing a dash. I'm just going to quickly make this look pretty, somewhat. Yeah, this is the definition of spaghetti. Anyways, that's pretty much what we're going to do. Now, the reason why we're doing it this way is because this dash cooldown timer variable we have is going to help us so much when we're trying to figure out how much time is left in the current cooldown, and that way the UI element is completely in sync with the actual player state. So the next thing we're going to go ahead and do is we're going to go back into our dash amount element, and we're going to go ahead and create a function. And inside this function, it's going to be called update progress bars. In the first part, we're going to make sure that any progress bar that represents a dash that the player has is full. And then after that, we're going to go and take a look at the dash that's currently being refilled, and we're going to make sure that it accurately represents how close the player is to gaining that dash. And then finally, any remaining dash bars, we just simply go ahead and just set them all back to 0% because, well, the player doesn't have that dash available to them. So first things first, what we're going to go ahead and do is we're going to get our progress bars, and we're going to right click and we're going to promote this to a local variable. And this local variable is going to be called progress bars that should be empty. And you'll see how we're going to use this in a second, but this is for the final step of this function. Next thing we're going to go ahead and do is we're going to go ahead and get a for loop. And our first index is going to be 0, and our last index, we're going to go ahead and get the player reference. And we're going to go ahead and get the dash amount. And then we're going to subtract 1 from the dash amount. And the reason why we're subtracting 1 from the dash amount is because we're trying to get a index for an array instead of just simply saying, oh, I want, -1 or -2. Because the way arrays work is that their indexes start at 0 instead of starting at 1 in C++. So because of that, we need to subtract 1 from the dash amount to get the right index. And that's why our first index in this for loop starts at 0. So what we're going to go ahead and do is from our progress bars, we're going to go ahead and we're going to get a copy. And that copy is going to be the index from our for loop. And then we're going to go ahead and we're going to drag out of that get copy. We're going to type in set%. And then our in% is going to be 1. After we do that, the next thing we're going to do is we're going to get the progress bars that should be empty. Drag out of this, type in remove item. And then we're just going to simply also get this get reference and remove it from the progress bars that should be empty. Make sure this is progress bars that should be empty, the local variable instead of the progress bars. So the next thing we're going to do is then from progress bars, we're going to get another get node, get a copy, and this time the index is going to be our dash amount. So drag out from the dash amount and feed it straight in there. Because of how indexes work, this is going to give us the index of the progress bar that needs to be filled. So what we're going to go ahead and do is we're going to go ahead and from this progress bar that needs to be filled, we're going to type in set%. And then we're going to go ahead and get the nice handy timer reference we made in the player a second ago. So from player reference, drag out of there, type in get dash cooldown timer, and just stay with me here. This is like very simple math, but it is a little bit confusing as to why we have to do this math. The reason why we have to do this math is because we can't actually get this timer is, the total length of this timer is X amount of seconds. But what we can get is the time that has elapsed and the time that's remaining. So in order to do this calculation, what we're going to do is we need to divide the time that has elapsed by the total time. So the way we calculate the total time is we get the time that's elapsed and add it to the time that's remaining. So first things first, drag out of dash cooldown timer and type in get timer elapsed time by handle. And then what this is going to do is pretty much this is going to give us how much time has elapsed from the timer. Then from the set%, drag out of there, type in get a divide node, and then drag this get timer elapsed time by handle to the top side. Next thing from this dash cooldown timer, drag out, type in get timer remaining time by handle. And then what we're going to go ahead and do is from get timer elapsed time by handle, we're then going to drag out of that, get an add. Then from get timer remaining time by handle, put that into the other pin of the add, and then take this add and then put it into the divide. And this gives us our total time, so that way we're able to divide our elapsed time by our total time, which will give us a number between 0 and 1. And that is what we'll set our % to. Then after we set our %, what we're going to go ahead and do is we're going to once again get progress bars that should be empty. Then we're going to remove item, and that item will be the thing we got. And then finally, last thing we're going to go ahead and do is we're going to go ahead and get a for each loop. And in this for each loop, we're just simply going to loop over all the progress bars that should be empty, and then we're going to set their % to 0. And then boom, the function is complete. So the next thing we're going to go ahead and do is we're going to go into this event graph, and we're going to do another set timer by event. So after this for loop is done, grab out of here, and sorry, I misspoke. We're going to set timer by function name. And what this is going to do is this is a more smart way of trying to effectively run an event every single tick when we need to run it. And you'll see what I mean by that in a second. So our function name is once again update progress bars. So let's type in update progress bars. And this is looping. And then max 1 per frame. And then what we're going to go ahead and do is we're just going to simply promote this to a variable. And we're just going to call this update progress bars status. And the reason why we're doing this is because whenever our progress bars are full, we don't want to be running this check every single tick because that's just, not optimized. So what we do is we actually will pause this timer. So pause timer by handle. And this will stop the timer from running, which then stops the event from firing. But in that case, how do we get the timer to start up again? Well, remember how in the Widget Blueprint UI, I went ahead and got the player reference? Well, this is why. So let's go back to our third-person character. And the first thing we're going to go ahead and do is whenever we perform a dash, and we do this, what we're going to go ahead and do is we're going to get an event dispatcher. So down here, add a new event dispatcher, and then say cooldown started. And then drag out into the event graph, call it, and add it to this right there. Then the next thing we need to do is down here, we're going to add another custom event, or sorry, not custom event, we're going to add another event dispatcher, and we're simply going to call this cooldowns finished. And we're going to go ahead and we're going to drag this into the event graph here, call it, and if you remember correctly, we have this set of execution pins down here, which basically resets the do once. Before we reset the do once, we're just going to call cooldowns are finished, and then we're going to reset. Compile and save. Next thing we're going to go ahead and do, go back to Widget Blueprint UI, and what you'll notice is now, if we look for our event, if we look for our new delegates, they're right here, cooldown started and cooldown finished. So what we're going to do is we're simply just going to add cooldown started from the player reference, and we go back here, and then add cooldowns finished. The next thing we're going to do is we're going to get our Widget Blueprint dash amount element, and all we're going to do is we're simply going to type in get update progress bar status. And we're just simply going to unpause the timer. Unpause timer by handle. Great. And then once all the cooldowns are finished, well then we do the exact same thing. We then drag out of here, and then we type in pause timer by handle. And then just as kind of a, edge case solver slash, just in case, drag out of Widget Blueprint dash amount element, get progress bars, and then just do a for each loop and make sure you set all their percentages to 1 because all the percentages have to be 1 if the cooldowns have been finished. Great. So now if we go back here into our player and we make sure that we have, let's say 2 dashes, let's see if this works. So we right now have cooldowns paused. If we dash, it doesn't work because I'm stupid. Yay. Hey, so I figured it out. I thought I was being slick, but I wasn't. So go from pause timer by handle, don't do that. And also make sure your time is 0.01. Of course, everything we did before, so, the whole event delegate system and also the delegates in the UI, that's perfectly fine. It actually works. It's just we need this progress bar to effectively update at least once for whatever reason. I don't know why, but yeah. Now if you play the game, you'll notice that our progress bars accurately represent the players, dashes, and their refill speed. Now what you may notice is this massive amount of errors, and the reason why is because we're actually calling the event every tick. And the reason why this is happening is if you click on one of these errors, you'll notice that it's this get percent and it's from the get dash amount. And the reason why is because if our dashes are full, then this just doesn't work because, well, the index doesn't exist. So the way we quickly fix that error is all we have to do is just simply get from this get, do an is valid conditional check before anything. So get from completed, drag out here, type in is valid, get this question mark, and then simply drag in our get. And what's going to happen here is hopefully, if we start playing the game, and we dash, we have no more errors. Because now, if the index doesn't exist, now the code just simply doesn't, run that. So now if we just wait for our cooldowns to refill, it completely works just fine. So yeah, there we go. And real quick, as just some quality of life for our dash element, pretty much let's just go ahead and change its position to be a little lower. But yeah, pretty much this is a dash UI element, and it can be in any position you want. And also, it adapts completely to your system. So maybe perhaps I want to increment the max number of dashes to, like, say 11. I don't know why you would do that, but now as you can see, there are 11 dash bars. And also, if we go back into third-person character, and let's say we set this back down to something more reasonable again, like 3, and let's say we changed our dash cooldown down to 2, then that change is accurately reflected within our dash bars. So yeah, I hope you found this tutorial helpful. If you're looking at perhaps making different classes in your game that might have like different parameters around their dodge. So for example, maybe a tank has has one less dodge compared to every other character, and the scout has a faster dodge recovery. Then then the UI needs to be dynamic to those changes in the environment. So hopefully this video taught you a little bit about how to do some dynamic runtime UI. Anyways, if you enjoyed this Unreal tutorial, please give me a subscribe and also give it a like. And if you want to see a specific tutorial next, let me know down in the comments. Otherwise, yeah, peace out, and I hope you have a great one.